Well, the title of my talk is not quite software engineering, it's how does software change engineering? Because as stuff gets embedded invisibly everywhere, software affects not just the software engineer, but the mechanical engineer, the aeronautical engineer, motor engineer, the architect, and everybody else. So what's the background? Well, for 10,000 years or so, since we figured out how to grow crops and herd animals, we've had enough surplus to build complex systems like cities, armies, civil services, religions, industries, markets. All these complex human artifacts used to be run in entirely local and physical and obvious ways. They were administered by known rules, by personal interactions, by authority, by small group relationships, or by exchange. And everything was, in some sense, visible and understandable to the participants. Here's some examples. Roman army, hierarchy. Chinese civil service, round about the same time, different type of hierarchy. Lasted a little bit longer. You could say it's what still runs China today. This is 800 years ago, kids sitting their civil service exam. Here, in the 1880s, we have a different type of complex system. This is a computer, believe it or not. This is how you did parallel processing 130 years ago. A contemporary of mine did a PhD in this and tracked down all the various algorithms used for sorting and searching and caching and backup and recovery and so on. It's all there. Hey, nothing much new under the sun. Here's another example. If anybody's ever been to Bombay, there's a system of 20,000 people there, mostly illiterate, who will fetch your lunch from home at 10 a.m. and deliver it to your place of work by 1. And it's all organised entirely locally by means of things like chalk marks and barrows and stripes of paint on tins, and it works. It's even going online now. You can go to the website and you can order a tiffin to be delivered. And therein lies the problem. Leslie Lamport, one of the great men in our field, once said the following thing: you know you've got a distributed system when you can't get your work done because of the failure of a computer you've never heard of. So all of a sudden, we've got a new failure mode. And this is, of course, of interest to us as engineers because it's failures that we learn from. So, we now find that we're becoming increasingly dependent on complex socio-technical systems, which are made up of people plus software. The internet itself, or the global card payment system, the global advertising ecosystem. If you're Google, you're interested in that. Smart grids for distributing electricity. DEC is gambling the farm on that. And then there's Facebook, and all sorts of other systems and platforms. But once you build a system that's of global scale, you get conflict and competition and complexity. The Facebook program that used to run at Harvard now has 900 million users. Israelis and Palestinians being mean to each other, Indians and Pakistanis. How do you cope with that kind of thing? How do you cope with having users who might be hundreds of banks who are in competition with each other? So in the research world, our funding agencies encourage us to think of new grand challenges. So here is a new grand challenge for people interested in systems engineering. We've got complex global scale socio-technical systems emerging as computers and communications become embedded invisibly everywhere. We depend on the internet, we depend on the payment system, we depend on all sorts of stuff. If the internet goes away, then your supermarket won't be able to order its deliveries on Thursday. They can always send what they sent last Thursday, but within a month or two you might find that the supermarket's full of toilet paper and dog food, and there's no vegetables or anything else. So this is a serious business, and how are we to understand complex systems, manage them, and improve them? Well, how many people have read Henry Petrosky's book, The Evolution of Useful Things? Well, if you haven't, I recommend it, because this is he's one of the really interesting writers on the history of engineering. And he's got a chapter in that book on the evolution of cutlery. And we see on the left here there are some forks from Iran from about 700 or 800 AD. And on the right there are some late 16th century French utensils, a knife and a fork. And up until then, people simply used knives to cut their food, and perhaps held the food in your left hand or held it with your bread. And so the French, before them the Italians, had the idea that why not make a miniaturized version of a carving fork and give one to everybody so that they could hold their meat and cut it. And then there's a fascinating story of evolution as people tried to work out the bugs in the knife and fork. Because if you've got a knife and fork as on the left, which is 17th century, then you can't use the fork to shovel food. So how do you shovel your peas? Well, the answer is you make a bigger knife. And as you go through the 17th century into the early 18th century, knives get bigger and bigger so that you can hold more peas on them. Right? And people then said, now hang on a minute, we're doing something wrong here, guys, because the fork, having a two-tined fork to eat your steak with is really inconvenient, because you've got to hold the steak like this, and then when you put it into your mouth, you've got to lift your hand way up, otherwise you stab the roof of your mouth. So they said, well, why don't we bend the tines of the fork? And gradually it evolved to what we have today. Of course, even in mid-Victorian times, there are still some very large pea-carrying knives around. And so the story of this and other technological evolutions is a slow process of complex and path-dependent evolution as designers, inventors, engineers work on whatever is most irritating about the technology in hand. Can't get enough peas on the knife? Well, hey, try the fork. We've tried everything else. So how does software change this? Well, software changes this because instead of taking 20 years for the next generation of cutlery, you can have 20 months or even 20 days to the next version of your product. Back when software was distributed in diskettes, maybe 20 months. Nowadays, it's all electronically updated, or it sits on hosted systems in the cloud. And this means that you can have monthly or more rapid than monthly new products coming out. Whenever you identify something that irritates people, you can just fix it. And Maurice Wilkes, one of the founding fellows of this academy, promulgated the law saying that everything becomes software in the end. So what's the catch? Well, the catch is that some things evolve very quickly and other things evolve very slowly. And in particular, the platform on which your software runs tends to evolve very slowly. And that's actually a good thing from the point of view of innovation everywhere else, right? So YouTube went to $1 billion company in a year because everybody already had a PC, a broadband connection, and a browser. But if there's something wrong with the PC, the broadband connection, or the browser, it takes you forever to change it because there are millions of companies that depend on it. What's more, at the level of economics, Lockin drives the industry, and this is what determines, directly or indirectly, what will or can be dependable, and also what sort of innovation is possible. So one of the insights that we had about a dozen years ago is that big complex systems were no longer breaking for technical reasons, but because the incentives were wrong. Alice guards the system, Bob pays the cost of failure, result, unhappy Bob. So various examples: if banks can dump the risk of fraud on customers or merchants, then fraud goes up overall. And if electricity generation companies don't have an incentive to provide reserve capacity, then you're going to have blackouts. So the dependability that we want is an externality, a side effect often of how the system is organized, and so is vulnerability, and so is fragility. So very often the properties that we actually want out of a platform system arise only by happenstance as a result of the self-interested striving of millions of players. And so over the past decade, we've developed information security economics as a discipline. We've got models of what's likely to go wrong. We've got measurements of what's going wrong, patching cycles and fraud and so on, recommendations for how to fix it, various reports now for UK government, for the EU, for the USA. In fact, one of my PhD students was poached and now does cybersecurity at the White House. And we've now got over 100 active researchers. And the interesting thing is this is now beginning to spread out into the more general problem of how do you do dependability rather than just security. Brief insight, for those of you who have not worked with IT platforms, by platforms we mean things like Windows or things like Facebook or things like Android, software, hardware platforms on which many other people write applications on which innovation happens. And three distinguishing features of platforms are, firstly, you've got network effects. The more people use it, the more valuable it is per user. So you've got increasing returns to scale. The second is you've got very low marginal costs. Most of the cost of writing Windows 8, many billions of dollars, was a matter of paying 3,000 people a salary for 3 or 4 years. And so that was the cost of the first copy of Windows 8, and every subsequent copy is essentially free. So if you get price competition, hey, price ends up being near zero, or actually zero. And that's why there's so much free stuff on the internet. Wikipedia instead of Britannica. Zero is actually the market clearing price for information, unless you've got something like network effects or Lockin to stop it. And the third thing is technical lock-in, because software that runs on a PC won't run on a Mac. And in fact, economists have studied this, have managed to show that the value of a platform is equal to the total lock-in of all the users. So if you're building a platform, you'll try and lock in your users like mad. And once you've locked in the users, it's going to be worth an awful lot of money to you. And so the market race to dominate is a very, very high stakes race indeed. And when people do that, if it's PC versus Mac in the 80s, or Symbian versus Palm in the mid-2000s, or Facebook versus MySpace 3 years ago, or iPhone versus Android right now, then an obvious strategy is to have no security in the early versions so that it's easier for everybody to develop apps for you. And then once you've won the market, you lock them all down. And this is why you end up seeing one platform after another being insecure, at least in the beginning, and security then being defined in terms of the platform owner's interests. And this happens beyond technology. If you want to set up a payment network, for example, it's a two-sided market. You need cardholders and you need merchants. So in order to get the critical mass, you have to appeal to the merchants, which means that if you're peddling something like EMV, you say to the merchants, you get the customer to pay by chip and pin, you won't be liable for disputes anymore. Also the merchants, we like that idea, where can we buy some terminals? Hey, hey, guess what happens to the cardholder? So here is exactly that example, which was mentioned earlier. EMV was introduced from 2003 to 2005, and the idea was that the merchant would be liable if a PIN wasn't used, and a cardholder would be liable if it was used. And banks thought, well, this is really rather super, isn't it? Fraud's no longer a problem. And this here is what happened. That fraud was shifted around. Some types of fraud went down, others went up. Mail order, telephone order went up. Counterfeit card went down initially, and then people figured out that they could put Trojans into chip and pin devices and steal people's card data, make magstripe clones and use them overseas. So fraud went up again. And now fraud's on the way down again. Some of that is improvement in the system. Other aspects of it are the fact that merchants and cardholders are paying ever more of the liability. So we heard of two programs on Newsnight back in 2008. We looked at chip and pin devices that had supposedly been certified as secure under the common criteria. And it turned out not to be the case. Visa and others were claiming that the devices had been common criteria evaluated when they'd never been through the common criteria process. So we pointed this out to GCHQ, who wasn't prepared to defend the brand, and the Banks Association said this wasn't a problem, but within a few months it was, because we found that there were people who had been putting Trojans into chip and pin devices in a warehouse in Dubai, en route from the factory in China. So merchants and indeed banks were getting chip and pin devices new out of the box, installing them in their shops or their bank branches. Customers would go in and use the card, and their card details would be texted all the way to Karachi. Bingo. How did that fail? Well, nobody was stepping up to the plate. Everybody was cutting corners. There were all sorts of bad incentives internally within banks, within the banking industry as a whole, and between the banking industry, the merchants, the customers, and of course the certifiers and various other players. Second failure, again, I used to play a video clip at this point of a Newsnight program, but perhaps that's better not done today while we figure out whether Newsnight will still be around or not, and if not, we'll have to go and break another system and get a video clip from some other program. But hey, the point of the no-pin attack, which was the one that we found afterwards, was that we had information, complaints in fact, from a number of very believable cardholders that their cards had been stolen and then used to buy stuff, although their PIN couldn't have been compromised. And the bank said it must have been, and so they wouldn't refund. And so we found that it was possible, if you put a device between the chip and PIN device and the chip and PIN and the chip card, that you could persuade the device that a PIN had been accepted by the card, whereas the card was convinced that a signature had authorized the transaction. And this means, in effect, that you can use any stolen card in any merchant terminal without knowing the PIN. So this appeared on Newsnight in February 2010. Some banks fixed the problem, but the fix was removed later that year, we believe, because it was causing too many false positives. So people have now been on trial in Paris for stealing hundreds of thousands of pounds using this, and they developed it independently from us. Again, when we look into the cause, the specification got out of control. There was something like 2,500 pages of chip and PIN specification, 1,500 pages of UK-specific stuff. Nobody's actually responsible for it anymore. You've got 100 vendors, 20,000 banks, millions of merchants, and there's just a big hole in the middle where the governance ought to be. So how does this affect individuals? Well, government figures for crime aren't that useful anymore in this space because a few years ago the government decided that fraud should be reported to the banks rather than to the police. And this was satisfactory for both governments and the police because the fraud figures went down. But it was less satisfactory for individuals. So the best figures we have to go on are the British Crime Survey, where Annex C occasionally comes out with figures on computer crime. And for 2009-10, the last year that they did this, we find that there's about a million traditional acquisitive crimes like burglaries and car thefts and so on, and slightly more than twice that number of frauds. Now, they don't disambiguate dodgy door-to-door salesmen from online stuff, but I think it's clear that online is most of it. So what this tells us is that in volume terms at least, cybercrime is now most of property crime. And one curious thing that was brought to my attention just a week or so ago is that the Scottish government recently did a survey with over 10,000 households interviewed in person. And now in Scotland, fear of cybercrime and online crime is rated as the main fear of crime by some 58% of households. And given my countrymen's reputation for mayhem on a Friday and Saturday night, that surprised even me. So, why should we study the costs of cybercrime? Last year there was a report by Detica to the Cabinet Office which said that cybercrime cost the UK £27 billion, or 2% of GDP. And this echoed an earlier claim made by AT&T to the US Congress. But when the report was published, people essentially rolled on the ground laughing, and various websites that do statistics on government reports tore it to pieces. And so Mark Welland, the previous Chief Scientific Advisor at the MOD, asked if we could come up with some more defensible figures to use as a basis for policy. So we assembled a dozen people who are experts in various aspects of this, and we considered a number of cyber crimes and did the best that we could from the available data sources to figure out what was going on and how much it cost. Now, there's a number of types of cybercrime to worry about. The pure cybercrimes that never used to exist 15 years ago, fake antivirus and stranded traveller and so on. And then there's the transitional stuff, crimes that have been around for, generations, at least 50 years or so, but where the modus operandi has changed, such as card fraud. And then the traditional stuff, such as tax and welfare fraud, that's now technically cybercrime, because people file their VAT returns online. So if there's a carousel fraud, that's now cybercrime. And we produced a report on this that came out in June, where you can get all the gory details. But one interesting thing that we learned that surprised even us was to do with the distribution of costs and the really skewed distribution of direct versus indirect costs. You see, traditional frauds like tax and welfare fraud are costing each of us a few £100s or so a year. And almost all of that is the direct cost. Only perhaps 15% or so are the costs in anticipation, the preventive measures, and the costs in consequence, such as chasing down tax evaders and locking them up. If you look at transitional frauds like bank and payment card fraud, then the cost to each citizen is a few tens of pounds a year, and the direct costs and the indirect costs are roughly balanced there. Whereas when we start looking at the new cyber frauds, such as fake antivirus and spam and so on, then the overall cost to each of us is a few tens of pounds a year, but almost all of this is in the form of indirect costs. For example, if you look at spam, something that we do a fair bit of, we've got a couple of servers in the lab where we collect spam and spam feeds and phishing takedown feeds and so on. It turns out that the biggest botnet in the world, the Rustock botnet, sent about a third of all the spam that was sent in 2010. And we know with a fair amount of precision how much these guys earned, because there were people in UCSD who made test purchases and tracked them through the system, tracked them through the banking system, analysed the stuff that they got back, and even took over some command and control servers so they got decent statistics on what the conversion rate from the various marketing campaigns was. And so we know that certainly to within an order of magnitude, the Rustock operators made $3.5 million from selling all this Viagra. But they sent a third of all spam, which costs about $1 billion to deal with. So for every dollar these bad guys in Moscow put in their pockets, they're inflicting costs of $100 on the rest of us. And that's actually quite remarkable. It tells us that we are not really any good at dealing with cybercrime. And there's a whole lot of reasons for that that are quite interesting. The fact that it's globalized, for example, and the fact that it's industrial scale petty crime mean that it's very, very difficult to get the police, say in London, to take a sustained interest in it. Suppose you're the commissioner of the Met, and suppose this morning one of these guys in Moscow sent out 1 million fish. Now London's 1% of the internet, so you'll see about 10,000 of these arrive in your manor. So going and chasing some bad guy in Moscow will probably cost you £500,000. A couple of staff time for a year, plus badgering the Foreign Office, plus blah, 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 blah. And there's no and there is no certainty that you'll get a conviction. It happens sometimes it doesn't happen. So there's an enormous temptation on you as the commissioner to say now, hey, the FBI will have seen 200,000 of these. Let them do the heavy lifting. And that's exactly what we see. Of state-level expenditures on cutting cybercrime, most is spent in the USA. About $100 million are spent federally between the FBI, the Secret Service, and the National Cyber Forensics Training Alliance, which is the hub of that wheel, and about the same again at state and local level. And other countries largely free ride. So it's the same as in conventional defense spending, where the Americans have got 14 aircraft carriers and the rest of the world can not quite scrape 14 aircraft carriers together between them. We see exactly the same in fighting cybercrime. Everybody free rides off the Americans. But there's a curious thing here, which is that if you look at companies like Google and Microsoft and so on, they're spending maybe 100 million each. And the next tier down, the Facebooks and PayPals and so on, they're spending maybe 20, 40, 50 million. So the overall expenditure is largely private sector rather than public sector, but then again this private sector expenditure is targeted on a particular company's interests. Right? Google doesn't like click fraud. The guys who operate Hotmail don't like spam, and so on and so forth. So the third example is what happens with infrastructure. What about the dependability of the internet itself? Because if the internet were to be knocked out nowadays, perhaps by a cyber attack organized by the Iranians, if the Straits of Hormuz were closed, for example, then that would be quite a serious deal. Now, we know a reasonable amount about the dependability economics of utilities, and it's not all that encouraging. Because if there's a power cut, the utility loses so many lost customer minutes. There's a certain amount of revenue. But the economy loses a huge amount. And if the electricity goes off for more than 2 or 3 days, then economic activity basically stops. So how do you go about keeping things dependable? Now, one problem that we've tackled and largely solved is the question of how do you provide surplus capacity in the national grid. What we do there is we tax the market every day, and with the extra money that's raised, we go out and we buy spinning reserve from some of the power stations. But of course, as we move online and as software starts getting in the way, then everything becomes very much more complex, because you get the possibility of some players dumping costs on others. And the internet is a particularly interesting case because it's in transition. It used to be run, in effect, by about 20 big companies, the Tier 1 ASPs. But because of some consolidation recently, that's now down to one big player, one medium-sized player, a few parastatals, and some small players. So the communitarian approach to keeping things up is not necessarily going to work anymore. So we got commissioned last year by the European Network and Information Security Agency to look at what could break the internet and whether there's anything that governments could do about it. Now, the internet has done very well so far. Things like 9/11 and Katrina and recently the storm in the US East Coast were just a little bit of local bother that was easily routed around. But there are still things that could go seriously wrong. If we had a once in 500 years solar storm, for example, knocked out the North American power grids, then that would in effect bring down the internet because they're central to it. You could have a human infrastructure failure like a flu pandemic. If everybody stayed at home for 3 weeks just until it passed, well, people can maintain the internet from home by the magic of computing, but would you keep the power grid up if there was nobody out visiting the substations? Organizational infrastructure failure, that's perhaps a serious issue now that power and money are so concentrated in the internet, and some of the players are now so big that if they had an internal failure, there's nobody else who could provide the surplus capacity to cover for them. There's the possibility of serious bugs, for example, as we move to IPv6, and there's a possibility of attacks. So if I was running this sort of thing for the government of Iran, I would be thinking in terms perhaps of a zero-day exploit on Juniper routers. And of course, our security services worry themselves all the time that BT buying all its routers from a company in China creates a large potential vulnerability. What can we do about that? Well, you can go and read the full report if you want. Conclusions, we need to understand what's going on better by measuring it and documenting it. And that means not just understanding the technical stuff, the flows of packets, but the underlying business relationships. There are some technical things that we need, such as secure inter-domain routing that is practically deployable. That's being worked on through BGPsec, and we're doing some research on SDNsec. But the big difficult thing there is that is practically deployable. Even if you put some software in everybody's router, how do you persuade 50,000 ISPs to all turn it on, especially if it costs money, and the benefits of turning it on all accrue to the guy next door or to the public at large? And finally, people need to start doing drills, because untested disaster recovery plans don't work. But how do you do a drill for such a large distributed system? That's something that ENISA is working on now. So as a final comment before I move to my conclusions, the Academy is about to start thinking about wind power. And if we get an awful lot more wind power, that means that the electricity supply will be much more intermittent. And so what do we do about that? Do we lay an enormous cable across the North Sea and then pay the Norwegians to pump water uphill when all the fans are turning in Yorkshire? That's basically what the Danes do, and it's expensive. Or do we pay the French to build us 20 nuclear power stations so that we can keep the lights on when the fans stop turning in Yorkshire? And that's also expensive. So the vision people had from about 10 years ago is that you make the grid smart. You put CPUs and communications in everything that's attached to the grid, from the meter in your home to the windmills, the nuclear power stations, and you then somehow let that become a platform for innovations so that people can write apps on it, do new startups, do clever things which will match supply and demand. So people could offer all sorts of new innovative tariffs, whereby you could get tuppence off your electricity if you allowed the electricity to go off 40 minutes out of the hour during peak times. Well, they do this for air conditioners in America already. That's all very well, but the reality we have at the moment is that the current UK plans are to leave the meters in the control of the retailers. And the problem with that, and Britain's the only country in Europe that's doing it, is that the retailers want to preserve sales volumes. So there's no incentive to allow effective access to outsiders, or even to devise the interfaces that would enable people to interact with the system so that they could save energy when the windmills aren't turning. So the most you're likely to get out of it is some peak demand shifting, because there the interests of the retailer and the householder do coincide. But as far as doing anything more than that, the demand response that would be needed in order to reduce demand when the wind fell, you'd have to have mechanisms whereby your meter could talk to your home automation, to your car charger, to your immersion heater particularly, because that's the big switchable load in most UK homes. And that's just not being done, because it's not on anybody's checklist. And one of the reasons that this is failing is that it's a large centralised government procurement, unrealistic timetable. Centralised system was supposed to be built between March and October next year, and everybody from me to IBM pointed out that this was mad. So ministers now say it will happen from March 2013 to October 2014, but realistically this is a 7-year project being compressed into something like 18 months, and it's not going to work. And so the whole thing appears to be cruising for a bruising. So how can we do policy better in future? Rather than focusing on the specific failings of the Financial Ombudsman Service or the Smart Meter project, how do you change the systems so that this kind of mess becomes less likely in future? Well, there's something that both engineers and policymakers need to understand, that both innovation and dependability are tied up with the dynamics of platforms. You cannot get a platform which will allow innovation in the energy space if the people who control the majority of the fielded assets and who control the customer's access to the platform don't have it in their interest to allow that to happen, and if they've got ways to stop it. Right? That's not the only thing. There are many, many other things that have to come together to make platforms dependable and to make them support innovation. And this just isn't understood. When we went to lobby people at DEC, we spoke to the minister, we tried to explain this, we then stood in the corridor outside and tried to explain to the economists there what a platform for innovation is. And something that everybody in Google understands perfectly was absolutely Greek to the people in Whitehall. That's got to change. So what do we need to do as engineers? Well, we need to learn enough microeconomics so that we can understand things like network effects and regulatory capture and asymmetric information and all the other good stuff. Policymakers, for their part, need some technical literacy, and they also need to be exposed to enough case histories of where systems are failed and where innovation has failed, so that we don't end up getting these dumb decisions taken all the time. So what sort of things can we practically do? Well, at Cambridge we've had for several years a course on economics, law and ethics for computer undergrads, where we try and bring all this stuff across. And from next academic year we're offering a Masters in Public Policy course, an MBA for civil servants, where I'm running a mandatory module on statistics and systems. So everybody who graduates with our MPP will have written a computer program even if it's only to calculate the mean and variance of a column of numbers. And they will have had to study the report on the failure of the London Ambulance Service and been examined on it. So, you know, we hopefully that will raise us somewhat off the floor. The only problem with this is that Whitehall doesn't allow its civil servants to take a year off to do a master's. So we'll be full up with all sorts of bright young men and women who will influence the future, but they'll influence the future of places like Brazil and India and Singapore and Norway and so on, rather than the future of Britain. Nonetheless, you've got to start somewhere. Develop the course, make it work, and then roll it out later. If you want change at scale, then I think we're going to need changes to the civil service exam. At present, most civil servants come from a humanities background, and they are cosseted with an exam which plays to their strengths. You've got to very high levels of verbal skills, of analysis and reasoning, but when it comes to quantitative skills, all you've got to do is read a table and add up two numbers. Now, this is not right. If you have people going into the civil service with degrees in classics or whatever, they should show that they're able to write a program. And similarly, if you've got people going in with whose first degrees are in physics or engineering or whatever, they should show that they're able to write an essay. You need both. There are many other policy lessons, but I'll highlight one that's topical. Over the past decade or so, computing education in British schools has died away. It's been replaced by a subject called ICT, a subject that used to be known as secretarial studies. So instead of learning to program games on the BBC Micro, kids are now learning to use Microsoft Word, and it's really, really boring. Now, there's a number of people who have lobbied on this. CAS has been the keystone in this. It's a guerrilla movement of computer science academics and school teachers. And the Royal Society produced a report, and the BCS has been involved, and the Academy has also been involved. And Michael Gove suspended the ICT syllabus until September 2014. So now teachers can teach what they want, and those who are clueful are now teaching programming again. So our 11-year-old is now writing games in Scratch rather than learning to copy files, and that's great. And the Academy and the BCS are working on a new syllabus, but somebody has not got across to the officials in DFE that we also need to change the name. Right? The civil servants are saying, well, you can teach computer science if you want, but it's got to be still called ICT. And this is the fight that's going on right now. And the department is internally divided, and the ministers' spads are all in favour of changing, and the old guard within the department wants to keep it, and people say that they've been lobbied by schoolbook vendors, whatever. But what's actually going on is that we need to get a campaign together to persuade Michael Gove. So what we basically need to do is to get lots of influential people to write to the Secretary of State and say, oi, you know, our business is really suffering because we can't hire people from school who know how to program, and kids are put off computing because of ICT. You've got to change the name. It's toxic. We've got to get that message across to the Secretary of State. So, research agenda. How does it affect longer-term guys like me? Well, the online world and the physical world are merging, and this is going to cause dislocation, I think, for as long as I'm likely to be around, and maybe for as long as you'll be around. And there's all sorts of things that we need to understand what's going on. You need to be digitally literate, of course. An understanding of the basics of computer science is a great help. But it's also, I think, very important to understand the basics of microeconomics and how things like platform strategies and platform dynamics affect the possibilities for innovation and for dependability. Now, from the scientific point of view, you can think of us as studying a machine that's got lots of wheels moving at different speeds. But it's a very big, complex socio-technical machine, perhaps like the system of law, where precedents can be updated quickly, laws are updated, you know, on the timescale of a parliament, but constitutions take centuries to change. And similarly, we are studying systems with multiple moving parts, with multiple systems and subsystems at different speeds. And what we have to do is to equip both engineers and policymakers to cope with this new world, and that's going to be a fun challenge. If you want more, There's my webpage, there's our blog, and we've got a conference, the workshop of the economics of information security, which meets once a year and focuses on issues around this.
Really inspiring, and now we'll move on to the next phase of the evening.
Well, before we open up to the floor, and by the way, there will be some roving microphones, so please wait until the microphone gets to you before you actually ask a question, because that way we'll all hear exactly what you've got to say. I would just like to start off by saying you paint, I think, rather a depressing picture in terms of government and changes, and how that change is actually going to occur. Is there anything, you're obviously doing as much as you can, and other people are trying to change things as well. What else, is there anything else that can be done to actually improve the situation?
Well, I think we have to learn from how other countries do things better. For example, I was at a party on Saturday night with a couple there. She had been at school in the UK, learned ICT and was working as an animator. He had been to school in the Netherlands, had learned to program and was working as a toolsmith. And she was really jealous. So there are places in the world where stuff is done better. You don't have to reinvent the wheel all the time. You go, you look, you fetch, and you implement.
It sounds a very positive move in terms of getting the ICT course actually changed. But there was something crucial when you said those that are clueful will introduce Scratch, things like that, getting children to actually program themselves. But not every teacher, in the same way that a large amount of physics teachers, for example, are biologists, you're not necessarily, the ICT teachers are not necessarily going to have that sort of capacity, I suppose is the kindest way of putting it.
Well, the people who are leading on this are CAS, and they are a guerrilla movement, and they have got several dozen centres where people go and hold workshops, and basically what's happening is that ICT teachers meet each other and enthuse each other, because very often they feel very isolated in the school. They feel that they've got an unrealistically low status. They're considered to be doing cooking rather than chemistry, if you see what I mean. And so when they meet each other, it fires them up. And the vision is that you build on top of this, rather than going to teacher training colleges, which teachers don't actually visit after they've graduated, we instead build links with local universities which run night courses, and then there are many other things that you can pull in as well. The Raspberry Pi at Cambridge is just one example. There are many others.
What about the civil service? This sounds a tougher nut to crack.
The civil service, I think, is a very tough nut to crack. And I am forcefully struck when I've been doing public policy work on the European field, how Britain is competitively well behind places like France and Germany and Norway, where there's a sufficient number of high officials went to the Technische Hochschule or the École Polytechnique or whatever, that the lack of clue that one finds in Whitehall is just not there. But I was speaking to somebody at the government Chief Scientific Advisor's office, and he was complaining that people with science degrees in the fast stream of the civil service basically have to cover it up in order to advance. You know, like gay men in the 1960s. People who've got degrees in physics pretend that they're pure mathematicians in order to be socially acceptable to the people who studied literature.
I was quite interested the way you say that with your students you want to introduce a concept of ethics. What sort of ethics do you actually mean when it comes to security?
Well, ethics is about how you deal with the law-norm gap. Laws are there to fix those things that can't be fixed by individual action and need collective action. That's why we have states. But the law trails very, very far behind technology. And if you set up a company like Google, for example, and you do stuff that creeps people out, then 10 or 15 years later you'll find the European Union weighing in with a directive that completely hoses your business. So it's necessary, even at the most practical levels, to stop and think, well, hey, how is this going to affect other people? How will they react? How does this play out in the long term for us? What's the good thing to do? If you become rich and successful, you want to be seen as being a good corporate citizen rather than as being some evil banker who should be taken out and taxed.
Right, well, let's open the questions up to the floor now. If you have a question, please raise your hand and we'll get to you. If you'd like to say, by the way, if you would just say who you are, where you're from. If you don't want to identify yourself for any reason, that's fine. We're all about security and privacy here. If you go ahead.
My name's David from First Bus Graduate and Undergraduate Scheme. I'd just like to ask, is NatWest passing on a greater risk to its customers with the emergency cash product or innovating in their market?
Well, Get Cash, I believe, was withdrawn after an avalanche of frauds. And it was interesting to see how the different frauds were dealt with. Some people got their money back without quibble, and other people were told to go away. So it exposes interesting, shall we say, procedural instability within the bank's complaint handling.
Thank you.
Yes, gentleman at the back here.
Hi, Rakesh Sharma from Ultra Electronics. First of all, I'd like to come out of the closet and say I'm a physicist. Secondly, just following on from what you said, Professor, in terms of politicians and not being aware of science, how can we, as a collective group, encourage scientists and engineers to step out of the shadows as advisors and start entering into the limelight as the decision makers?
Well, if you want to be a decision maker, then you've got to run for Parliament. That's how we run things in our society. And there's a whole discussion about why scientists and engineers appear to be very, very less likely to do that than our numbers would suggest. There are, of course, other ways of influencing outcomes by means of single-issue pressure groups. And then there's the whole question of where power lies anyway. Now, after we set up FIPA in 1998, we campaigned on some local issues on the RIP bill, as it then was in 2000, and the Export Control Act. But we noticed increasingly that the issues that actually affected technology policy were happening in Brussels. And so perhaps the best thing that we did was to get together with various others and set up EDRI, European Digital Rights, which has now got a proper staffed office and which represents these issues in Brussels. To do more than that, perhaps you have to think of standing for the European Parliament.
It's an interesting issue because actually there are parallels there with journalism as well, in that in the newsroom, and I'll come out of the closet as a physicist as well, it's very unusual to get science graduates as journalists, but that's something that equally needs to be changed. Perhaps we wouldn't be in such a mess as we are already. I don't know. Thank you, Martin.
Ross?
Would you just wait for the microphone, Martin?
I've got my own.
Oh, that's true. Sorry.
Martin Thomas. Ross, I'm struck by the fact that you point out that software is getting in everywhere. It's getting into the critical infrastructure of a country, and most of the software that is getting into the critical infrastructure is written overseas. We're buying in large amounts of software and putting it in critical areas when it's being written in countries that may not have the best interests of the UK at heart. Do you see any solution to what looks like a significant and growing threat?
Well, some people worry about the potential risk from Chinese, as China makes the hardware and India makes the software. More people worry about the threat from Trojans in the hardware from China than worry about the threat from software from India. really, this is not something that the UK alone can do something about. We live in a global world now. We're no longer the British Empire. We're no longer price makers, we're price takers in essentially every market that matters, including the market for software quality. There are specific areas in which we may be able to do special things. But the best we can do, I think, is to keep on training up generations of young people to inspire them as computer scientists and engineers and encourage them to innovate and start companies and start contributing to the whole global ecosystem.
I have another question from the front here. While you're making your way across, are we in danger, Ross, of having a generation gap in that although positive moves are being made now, there are going to be basically effectively a generation who have missed out?
Yeah, people who are between 18 and about 35, perhaps about 30, have generally been blighted by ICT in schools. What can one do about that now? Well, hey, it's never too late to learn. But where are the support structures for that? Where are the incentives for people who are, early to mid-career to go and pick up new skills? That perhaps is a question for individual employers. So it's not just the civil service; it's also an issue for you if you're running a company.
Yes, please.
Philip Greenish from the Academy. Ross, we've seen examples in recent times of the failure of complex software systems, which have had some quite catastrophic consequences for the businesses concerned. The failure of the BlackBerry system only I think a few months ago, was it last year? RBS had a huge problem with their software upgrade. I think it was RBS, it might have been HBOS. We hear, one reads of flash crashes in stock markets where software systems do things, trading systems which have unexpected consequences. Now, are these the tip of an iceberg? As software systems become more controlling and more complex, are we going to see, do you think, more of these? Or are people who are designing these systems learning how to control them perhaps better?
Well, as software goes everywhere, we're going to see the good, the bad, and the ugly. The good is that you can innovate rapidly in the right circumstances. The bad is that you've got bugs and blunders and crashes, and the ugly is that you can have monopolies and other abuses. And yeah, we're going to see more of it. Now, how does industry respond? Well, the first bank to respond to this in a sensible way was, in fact, HSBC, which back in the late 1980s appointed its CIO to be a member of its executive committee, the four-man group of people who actually runs the bank. And more banks have now started to follow suit, because it's understood that around the table where real decisions are being made, you've got to have a geek, right? And that is operationally critical. Unfortunately, our government still hasn't got the message. If you look at the typical Whitehall org chart, the CIO is down here somewhere.
Can I perhaps pick up on that, Sue, as well? I have another question which relates to this lack of expertise within government. And I think from the way you talk and from the experience that I certainly have, I can't see that being resolved at the right sort of volume levels in the short term. If you look outside government, though, and if you look, for example, at 4 national academies that have expert fellows in each of them, with across every scientific and social science disciplines, and if you look at the access that academies have into their own specialist areas, we have strong working relationships with 36 engineering institutions, each of whom has strength in depth. Do you think there's any prospect of getting policymakers in government to make seriously better use of the non-governmental expertise that is readily and often willingly available to them?
Well, if only. The problem is that bodies like the academies and the NGOI chair and various other NGOs who've got relevant expertise are so often seen as just one lobbyist among many. And from the point of view of a busy minister trying to drink from the fire hose, this is entirely understandable. There was an article in The Guardian, for example, saying, well, why should anybody rejoice about the new Archbishop of Canterbury? He's just another pesky lobbyist. Why doesn't he take his place in the line along with all the rest of it? How come he's got 26 seats in the Lords? That's not right. If only we could swap the Bishop's 26 seats for 26 scientists, engineers and research medics. Hey. But nice though that would be, I don't see any practical mechanism to get from here to there. Perhaps what it will take will be some disaster which causes the Prime Minister of the day to sit up and say, right, we've had enough, we're changing the civil service exam, we're changing the way that we recruit, train and promote people to be people who can run big complex systems. Because that's all a government department is nowadays, right? It's a website. Right? It's a website, and you go there, and it demands that you put some information in, however embarrassing it might be, and it then says, here's some money, if you're lucky, or it says, give us some money, most of the time. Right? So you would expect that the sort of people who would be hired in the civil service would be the same sort of people who get jobs as engineering directors at Google. It couldn't be more different.
Right, we have a question from the back here, and then would you mind passing your microphone to behind you? There was a woman behind you. Actually, I thought maybe Melissa, you could hand that mic to there, and then we've got people set up, ready to go.
Thank you very much for a fascinating talk. My name is Rob Holmes, I'm a fellow of the Royal Academy. I'm not sure if I understand very much about this. I'm definitely not 35. In fact, I'm not even double 35. But I do use this stuff quite a lot, like everybody else in the room. And I think I'm getting to the point when I despair of decision makers or people who are on boards of companies, and I include myself in this, ever understanding enough about the technology that goes into exposing us all to this cyber risk. And given the statistic that you showed, which I thought was absolutely stark, that most crime is in fact cybercrime, although it's not necessarily to do with computers, but cybercrime. I'm really wondering if there aren't some very simple things that we have to do to avoid this, because actually there are plenty of risks in life, and deciding how much to invest in solving this one, it's quite a difficult decision. So, passwords, a lot of passwords are rubbish. People don't update their platform. If Windows is a platform, they don't take the updates. They introduce extra information via little thumb drives or whatever. And is it right that we should be going for more and more technical protection on the system, or should we be looking more and more at the way people use it and persuading, coercing even, people to obey the rules, which would deliver, I think, a lifebelt against most of the potential risks that we face in these big systems?
There's an obvious difficulty here in that if you look at a system like Facebook, for example, the default settings are insecure. You're sharing your information with the world and his dog. But the reason for that is that you're not Facebook's customer, you're its product. Its customer is the advertiser, and Facebook makes its money by providing the deceptive illusion of privacy when you don't actually have any, in order to get you to share as much information as possible that it can then sell to the advertisers. Now, it may very well be that in 10 or 15 years' time, the European Union will finally come up with a directive or action through DG Comp or whatever and fix that. But historically, this takes a long time, right? Governments act very slowly. There are other policy interventions that are less obvious, but that might also be extremely helpful. For example, in the case of online crime, we've held for some time that one of the best ways of reducing this would be changing the liability rules for disputed transactions, so that banks can't dump risk on customers the way they do in Britain and Spain and Latvia and some other member states in the European Union, but instead they had to carry the cost of it like they do in America and Finland and Netherlands and so on. And there's actually quite noticeable correlations coming across if you look at the Eurostat statistics, which we discussed in our cybercrime report. So there's a practical way forward for policymakers to deal with cybercrime. The only problem is that it's action that falls on George Osborne's shoulders rather than on GCHQ's. And if his priority is to be nice to the banks to get them lending again and get the economy going again, then that's always going to be priority number 117 in his pile.
Yes, please.
Lawrence Cullen, I'm spending a few months working in the Office of Chief Scientific Advisor. In my day job, I'm normally a civil servant. I work at the Intellectual Property Office. And I'm also a qualified scientist. I have 3 degrees, so I'm sitting here somewhat bemused by the comments about the inability of people working in the civil service to be able to appreciate some of the scientific and technology challenges you're talking about. And it seems to me that part of the difficulty we have is we educate our people to be highly specialised. So it's their inability to communicate with large groups and to deliver complex messages. Just in the way that part of the problem you talked about earlier on is the inability to design complex systems that actually work and function. And so it seems to me that the root of the problem is our inability to be able to take technological issues and have them understood by people at all levels of society. And it's, your solution would appear to be to get rid of the civil service, and so we just bring the thing down to the lowest common denominator, because it's basically what works in that environment, and whoever has the strongest protection is able to succeed.
Sure.
Are you advocating anarchy, Ross?
I'm not advocating anarchy. It's the sort of thing I might have espoused when I was about 18. But what I'm actually in favour of is reforming the civil service so that it works better, so that we recruit and train and promote people on the basis of their ability to do the job in hand, which involves having an understanding of technology and also understanding how to deal with people. So you either start with science and technology graduates and you give them the necessary polish that they can operate in a minister's private office without dropping a terrible clangor or making enemies or being thrown out, or alternatively you start with arts graduates and you train them up so that they understand the technology and the science enough by getting them to study, for example, relevant case histories during an MPP, that when they come across a problem, like how do we build a platform for innovation in the electricity markets, they at least understand that there is a problem there and the sort of people that they should go to get serious advice on it.
Question at the back, please.
My name is Stephen Dennis. My company is Blue Sky, and we develop software for our living.
Could you put the microphone to your mouth?
Well, I was speaking into a live microphone. So we develop software for a living, and my preoccupation, since we've now moved our entire development environment onto the web, onto the cloud, is really the notion of trust and resilience. Because we, like many other people, will not be able to run our business unless we trust and have a resilient infrastructure, which could be anywhere. I mean, my data could be hosted in Venezuela for all I know. So I'm interested for you to tell us a little more about the current thinking for, one, mandating trust and resilience of these vast networks, not just communications, but also the data centers. And also, how do you begin to put together a plan that would test the data resilience or the resilience of the internet? These are huge questions upon which my business relies.
Well, the resilience of the internet is how long is a piece of string question. Because if you use the internet to speak to your uncle in Australia over Skype, then 90% availability is fine. But if you're delivering cloud-based services to your customers, you need 4 nines or better. And you may in fact be limited by the availability of the electricity grid or your DSL line or other things that are outside control. As far as the trust in the cloud-based service providers is concerned, there are many complex issues around that. But from the point of view of a small business, you're almost certainly likely to be better off and better protected using large firms than rolling everything yourself. I mean, Google hires 150 or so people with security PhDs, and they're much more capable, I would think, than GCHQ. They get all the attackers that Cheltenham gets, plus an awful lot more beside. That being said, it's always prudent not to put all your eggs in one basket, and although you may use a service provider like Google or Hotmail or whatever for mail, and you may use somebody like Amazon for providing the hosting for your apps, you have to be wary of lock-in. So make sure that the stuff that you're building will run on Amazon, will also run on Rackspace or wherever. Make sure that you've always got backups, physically on your premises. Download the stuff once a day or once a week or whatever. Make sure that you've got a backup and a backup on the backup, and make sure that it's always tested. If security and dependability are really important to you, you can't outsource it all. You've got to remain in control of it.
Well, I have to say that W ticks all of those boxes so far. I mean, you have to diversify. Trust.
Hopefully you'll sleep a little bit sounder than tonight knowing that. Did you have our final question, please?
Thank you. Is this on? Jenny Woods. I've come here tonight from a 2-day conference that's been running in London called Spot On London, if I remember correctly, which is science policy acquisition tools online, where there have been 200 enthusiastic young scientists learning how to engage with policymakers. So in contrast to your sort of atmosphere of depression about engaging with policymakers, they're learning the tools to how to do that. And I would just wonder whether the Academy might be interested in perhaps joining up with that. It's an annual conference or running something parallel to get your young technologists into that same space, learning how to interact with MPs, with civil servants, and actually making the change that we all need to see.
Well, that's a question obviously for Philip and Martin.
That's really interesting, and we'll certainly follow it up. Thank you very much.
Good, well that's a very positive note to end on. Our thanks to Professor Ross Anderson for this fascinating conversation.